Hello everyone. In this video, I want to show you something really interesting about Coppelia, and that is how to connect it with MATLAB and how to get data from that in MATLAB. So here you can see this is a video of a Sawyer robot, and this is a vision sensor looking at it. This is the floating window in Coppelia, and here is a single shot that I got from this sensor, as you can see, and I'm showing it in MATLAB, as you can see here, with some code that will connect them together through the API, remote API. So how is this one done? Here is the part that I want to show you. So let's go ahead and see what we need to do. So the first thing you need to do is when you are in your local drive where Coppelia is installed under program files, right? So this is Coppelia. You go in and then under programming, here you go to this folder called Legacy Remote API, and then you go under this one called Remote API Bindings. Okay, this is where some of these needed files are stored. Then you go under MATLAB, and then you need to copy and paste in your MATLAB folder two of these files. Which two? This one and this one. These are sample demo files. So this REM API and this remote API proto, they have to be copied in your local folder where this MATLAB script is that is going to plot the image from the Coppelia. By the way, I'm going to give you this MATLAB code so you can use it. And there is one more file that you need, the DLL file, remote API DLL. Now, where is that one? So if we go back here, the next folder you want to go is to go under lib or library. And if you go under library and go inside of it, and then you need to, based on your operating system, for mine is Windows, so I go to Windows, and this is this file here, remote API DLL. That should also be copied into the local folder. Now that I got these three files, here is the MATLAB script that does the job, and I'm gonna go over that. But before that, I need to tell you what to do in Coppelia. So the first thing you do in Coppelia, you add a very simple script as a non-threaded child to the scene. And in this script, there are only two things you want to do. One, use this command sim remote API.start, and you provide a port. In my case, I'm using this available port here. And then whenever whenever you stop the simulation, you want to use the stop command of that to stop the remote connection. Okay. So when you start it, the remote connection starts. When you stop it, the remote connection stops. For that reason, whenever you want to get the data from Coppelia into MATLAB, you need to make sure that your simulation is running. If your simulation is not running, there will be no connection. So once this one is running, that the start is that part in the code is going to start the connection. Now let's go ahead and I mentioned that here in the MATLAB code. Now it's running. What would you do? The first thing that you do from this M file, you're going to pass to it this from this REM MPI, you pass to it that remote MPI API, in quotation mark. And this one is defining for you the connection object. Here I call it sim. If you want, you can call it Coppelia. You can call it whatever you want. It's just the name of a basically connection object. Okay. Now, the first thing you do, make sure that if there are any open connection between MATLAB and Coppelia, you finish it first. If there is one open and you try to open another one, you're going to get an error. So first you say, hey, sim.simxfinish -1 means close anything that does exist, any open one. Now that all of the open ones are closed, it is time to start a new one. So you say, hey, simx start. you provided basically what? So here is the syntax for it. You provided the address, which in this case you have to use this address, okay, for Coppelia. Then you provided a port, and the port here is the exact same number that you had in Coppelia. Okay, if you use any other port number than this one that you provided in Coppelia, it is not going to work. So these two numbers should be the exact same thing. Okay, and let me see if I have something about it. No. So let me add something. Use the same port that used in Coppelia script. Okay, if you use any other one, this is not going to work. And then you have a couple of things. The first one is we call wait until connected. You say true. So here you wait until you get the connection. Then the next one is called do not reconnect once disconnected. You also said that true. So once you get disconnected, this one is not going to try to connect again. Then you give it timeout in milliseconds. In this case, 5,000 means 5 seconds it tries to connect and waits for the connection. And if it doesn't receive anything, then it is going to basically disconnect or stops trying to connect. And the next one is called the thread cycle in milliseconds. What is this one? This is the communication thread cycle time in milliseconds, which here we're going to use 5. And you can change these numbers if you want. You can change this one, you can change this one. This is the only one, and this one that you have to be exactly using these numbers, especially this one, the same number as Coppelia, and this one exactly this address. Otherwise, you're not going to get any result. You're going to get error. Now, this one will give you back a client ID, in this case, the ID of the CoppeliaSim, okay, the connector for that. So now, if this is not a negative number, if this is a positive 0 or anything, you say that, hey, I have connected to the API server. So this is just to show that you could connect. Next, that you're connected to Coppelia, now you can go ahead and connect to anything you want in it. Like what? Let's say I want to get the vision sensor. So if I go here, you see that I call this guy vision sensor, and it has to be the exact same name, right? No upper or lowercase missing, a mismatch. So you say, hey, go to that ID, go to that Coppelia, look for this object and get the handle of it, okay? And return the sensor handle, and this result, whether again this is -0 or something, it will tell you whether you could get that handle or not. Now here you have some kind of option that you have for getting the sensor handle, and a similar option like this is used next when we want to get the image from the vision sensor. This one called SimX operation mode one-shot wait. What is this? I'm going to explain it in the vision sensor. So I'm going to explain exactly what this one-shot wait means. So now that I could get the handle of the vision sensor, and again, I can check this variable to see, hey, I could find it or not. Now I'm going to pass it to the next command, which is called SimX get vision sensor image 2. And please pay attention, you might use this version called just vision sensor image without this 2. If you use that, you're gonna get into a bunch of errors. So make sure this is exactly image 2. What would you pass to it? You pass to it the client ID, which is Coppelia. You pass to it the sensor handle, which is the vision sensor. Here, this one basically is some options which we don't care too much about. The most important one is this guy, the operation mode. So how do you want to get the data from the vision sensor? That is something we need to talk about. So there are a bunch of different operation modes for this remote API connection. And here I have provided 4 of them for you. The first one is called SimX op mode blocking. What does this do? So this one executes the command, in this case, getting data from the vision sensor, and then it waits for the Coppelia reply. Okay, so it executes the command and waits to see if Coppelia is giving it the image or not. The important thing about this, you use this if you have a one-time query, okay? Like you want to get one-time object handle or so. So in this top one, you could have used that as well. The next one that we are using here, the one-shot wait, it sends one command and then waits for the immediate result. Again, this is good really for single data read or single data action. And again, for the image, since we are reading a single data, this is good. The next one is called streaming. So this is good when you want to start or maintain a back data stream, okay? So if you want to continuously read images from the vision sensor or any other sensor, instead of one image, you want to read a stream of images, then you're going to run it in this mode. And then there is a buffer mode, which retrieves the latest value from an active stream. Okay, so not only it gets the stream, also it retrieves the last one. It gets the last one from the stream. And when is it used? This is used after the streaming is initialized and you just need to read the current data efficiently. So it looks into the stream and it gives you the very last one very efficiently. Okay, so in this case, we just want a single shot from that sensor, so we use this guy here. Okay, now what does this give you back? It gives you back a variable again, an integer that it can tell you whether the status of this command was successful or not. It gives you the resolution of that sensor and it gives you the actual image, which you can easily show with the command IMShow. And you can see that in this case, look, the ret variable is 0, bigger than negative, which means it was successful, or -1. The resolution of the vision sensor is 512 by 512 and the image. And you can see that it is actually a 512 by 512 vision sensor, okay? So let me show you that here, you see? And you know, one good thing about the vision sensor is you can change the resolution of that as opposed to a single camera. Cameras, you cannot change the resolution. Vision sensor, you can change the resolution. And that is good because initially I used the 256, which is the default, and the image I got in MATLAB was really pixelated. So I resized the image to 4 times bigger, 2 times in both directions. And now the image you'll see that I have in MATLAB is a much cleaner, nicer image. There we go, done. Now, if you want, you can basically talk back to Coppelia. So not only you can get data from Coppelia, you can send something to Coppelia. Like what? Look at this. SimX add status bar message. So you can now send something to Coppelia status bar message. And in this case is to say, hello, CoppeliaSim, sending a message from MATLAB. And that is exactly this command is doing. Look, it says go to that ID, give it this text, and again, do it as a one shot. You see that? Okay. And here you can use this command, get ping time. This is just to guarantee that the last command that you sent had time to arrive, okay? This is not really something that you need in this code, but it's a good thing to have. And the most important thing, now that you're done, you're gonna finish it. You're gonna close the connection. Never leave it open, okay? If you cannot do it, any of this, then of course it says fail to connect. But if you could do it, it is gonna do all of these things. And finally, that object that you started for the remote connection, you're going to delete that as well and release the resources. So you see here, while this one is running, now we're gonna run this script in MATLAB and boom, beautiful, huh? Yeah. So now let me go to Coppelia and I'm gonna move my vision sensor to somewhere else. So let's see here if I can move it. I need to stop the code and then the simulation. And I'm gonna move it to another location here so you can see that it is really doing the job. So I'm gonna move this in the X direction and Y direction. So I'm gonna come here, right? And then I'm going to rotate this about the Z of the world. So go something like this. So now look, this is what you have, okay? Yes. And now if I run it in MATLAB, I should get a different image. And there we go. You see? So perfect communication back and forth between MATLAB and CoppeliaSim. So as I said, I'm gonna share this MATLAB script with you, as well as, of course, this simple Coppelia script. And hopefully now that you know how to connect, you can get the amazing data that you can get in CoppeliaSim, and it's not as easy to generate in MATLAB. You can bring them into MATLAB and you can do lots of further processes. You know, because MATLAB image processing computer vision toolbox is insanely good, but the simulation part of the robotic systems is not as good as Coppelia. So you can do your simulation in Coppelia, send your data to MATLAB, and do the processing in MATLAB. And this is the beauty of this connection. So hopefully it was useful to you. I'll see you in the next video.